Hi, I'm Joel with Arzell Zoning Tech Support.
And I'm Jason with Arzell Zoning Tech Support.
And today we wanted to talk to you about maximizing the performance and comfort in your home. We all have hot and cold spots in our home. The upstairs and the downstairs are usually very different when it comes to the temperature. But with zoning, we can control those and we can maximize the performance and comfort in your home.
So how would you say that our products help improve your energy efficiency of the home?
So when it comes to the energy of your home, there's two different ways that you can use a zoning system. You can keep the entire home at the exact same temperature, or you can use the home based on your actual schedule. How many homes are so much larger than they need to be for maybe two people? You have your empty nesters, you have people who are just buying a new home for the first time and they don't have a whole bunch of people living in there. How much of that home do they use at any one time? That's usually a very small portion of it. So if we control the temperature from the areas that we use our homes at, studies have actually shown that by setting back the rest of the house, there can be energy savings anywhere from 15 to 30%. However, if we try to condition the entire home at the exact same temperature, we just want to even out the temperature difference. Zoning does that very well, but our energy savings aren't really there.
So if a homeowner is going to be adding an addition or adding to the existing footload of a home, how could zoning help improve air delivery?
Let's say maybe they didn't have the space for having a second furnace in the house. The existing ductwork is designed for the house the way it is at the time of construction. But once you add an addition onto that home, you have two choices. One, you rip all the ductwork out and you start from scratch to design that ductwork so it can handle that new addition. Or two, you add zoning. Because maybe you've added a new room onto the back of the house. You've added a new suite. You've got some family that's moving in and you wanted to provide space for them, but you have a two-story house. That upstairs is probably going to need conditioning. That new room's probably going to need conditioning, but the main part of the house probably won't. So by adding zoning, we can direct the air from the main part of the house where it's comfortable, and we can send that to the addition without having to do any major duct modifications or without having to upsize the equipment.
I've heard that zoning can reduce the life expectancy of your HVAC equipment. Is this true?
That's really a common misconception. The reduction of life on the equipment comes right down to actual design. If my furnace is already too small or too large for my ductwork, so my ductwork, I'm running high static before I even put zoning in, then I'm going to run into a problem with life expectancy on that equipment. Normal design application without zoning is your ductwork should be between 0.4 and 0.5 total external static pressure. Once we apply zoning, we want to push that up closer to the maximum that the blower performance data chart allows for in the furnace manual. So with our smallest zone calling by itself, we want to see that around 0.7. We're within that range that we look for, and that's not going to have any impact on the equipment life.
A term most homeowners wouldn't be familiar with is thermal shift. Can you explain that and how it affects the environment in the home?
So we have northeast, south, and west. A northern wind is cold, a southern wind is hot. That's going to change the thermal gain of the home. But you also have your sun rising and your sun setting, and as it moves around that house, that's going to create thermal shift as well. So it bakes this part of the house at this time of day, it bakes that part of the house at that time of day. So when we're designing for zoning and we split the home up, we might do upstairs, downstairs, we might do east and west, and that's going to allow us to direct the air where that thermal shift is happening at.